Hey everyone, welcome back to Wrath of Math. I'm your host, Sean Ian. In today's video, we'll be going over how to add and subtract complex numbers. Now that we know what complex numbers are, it's important to learn how to perform operations with complex numbers. So that's what we'll be doing today, starting with addition and subtraction. So remember, we know that complex numbers are numbers of this form, a plus bi, where a and b are both real numbers and I is the imaginary unit, which has the property that when squared, it's equal to -1. And now we'll put some parentheses around this just to make clear that it is itself a complex number, and to that we'll add another complex number, c plus di. Again, c is a real number, and di is a real number multiplied by the imaginary unit. Any of these variables, a, b, c, or d, could be equal to 0, but they also might not be equal to 0. They can take on any real number value. So adding complex numbers like this is pretty straightforward. For starters, we can just drop the parentheses. The parentheses aren't actually important. When you're adding stuff up, you can put parentheses wherever you want, and it's not going to change the sum. So we can rewrite this as a plus bi plus c plus di. And now all you're doing is adding like terms. So you add a to c because they're both real numbers, and then you add bi to di because they're both imaginary numbers. So what we end up with is a plus c, this is the sum of the real number parts of the two complex numbers we're adding, and then we have plus the sum of the imaginary numbers in the complex numbers that we're adding. So this is b plus d, and they're both getting multiplied by I. And this is, in general, the sum of these two arbitrary complex numbers. So let's look at some actual examples. And remember, all we have to do is add the real parts of the complex number and then add the imaginary parts of the complex number. So let's get into these examples. So let's say we have 2 plus 3i, and to this complex number, we're adding the complex number 4 plus 5i. And again, you could drop the parentheses if you like, so we have 2 plus 3i plus 4 plus 5i. And doing this addition works just like adding like terms with a variable. So if we had something like 2 plus 3x plus 4 plus 5x, this might be more familiar to you if you've done algebra before. You would know you just add 2 and 4 because they're like terms, and you add 3x and 5x because they're like terms. So you would have 6 plus 8x. And we do the same thing here with the complex numbers. So we add 2 and 4 because they're real numbers. So we have equal to 2 plus 4, which is 6. And then we add the imaginary numbers, 3i plus 5i, which is just 8i. So 2 plus 3i plus 4 plus 5i is just 6 plus 8i. We added the real numbers to get 6, and we added the imaginary numbers to get 8i. Now let's look at a slightly more challenging example. Let's say we have 3 minus 2i, so we're getting some negatives in here, and to that we're adding 5, let's say minus 3i. For these problems, I think it's often useful to think of things like this minus 2i not as subtraction, but as the addition of a negative. So we can rewrite this as 3 plus negative 2i, and then adding the other complex number, we have 5 plus negative 3i. So these two sums are equal. We just switch the subtraction to the addition of a negative. And the reason this is useful is that now we can move these terms around. Addition is commutative, so now that we're adding everything, we can shift everything around. So now it works just the same as before. We add the real numbers and we add the imaginary numbers. So adding the real numbers, we get 8, that's 3 plus 5, and then negative 2i plus negative 3i, that's just negative 5i, so we have plus negative 5i. That, of course, is equal to 8 minus 5i. So the sum of these two complex numbers is equal to 8 minus 5i. So when you have subtraction in these complex numbers and you're adding them up, just think about it as the addition of a negative, and then the process works just the same as before. You just add up the like terms. Now let's quickly look at some subtraction. Let's say we had a plus bi, and from that we're subtracting the complex number c plus di. Now, if we're going to drop the parentheses here, we first have to distribute the negative through this complex number. Before, when we had a plus between the two complex numbers, we could imagine there was a positive 1 here. Multiplying the 1 through the complex number doesn't change anything. But now we have a subtraction sign, so you can kind of think of it as there being a negative 1 in front of this complex number now. And multiplying it by negative 1 definitely does change it. So if we rewrite this without parentheses, we get a plus bi from the first complex number, and then for the next complex number, we have to distribute this negative. So we have negative c and negative di. So we have minus c minus di. And again, you could think about this as the addition of negatives rather than subtraction. So we have a plus bi plus negative c plus negative di. And then it's exactly the same as before, just add up the like terms. So we get a plus negative c, which is the same as a minus c, and then we have bi plus negative di, which is the same as b minus d, all multiplied by I. So if we have the difference of two arbitrary complex numbers like this is what you get, a minus c plus b minus d times I. That's the difference of the real parts plus the difference of the imaginary parts times I. So now let's look at some examples. Let's say we have 5 plus 3i, and from that we're subtracting 2, let's say plus 2i. So then if we rewrite this without parentheses, again we start with 5 plus 3i, then we have to distribute the negative, so we have negative 2 and negative 2i. So we subtract 2, and then we subtract 2i. And then again, we can write this as the addition of negatives rather than subtraction. So plus negative 2 and plus negative 2i. And of course, this rewriting is not necessary, but now all we've got to do is add up the like terms. So we have 5 plus negative 2, those are the real numbers, that gives us 3, and then 3i plus negative 2i, those are the imaginary numbers, that's just plus 1i. And comparing this to what we started with, you can see that what we have is just the difference of the real numbers plus the difference of the imaginary numbers. 5 minus 2 is 3, 3i minus 2i is 1i. Alright, so that's great. Let's look at one more example with some negatives alongside the subtraction. So let's say we've got, negative 3 plus 5i, using a lot of 5s, and then let's do minus negative 2 minus 3i. So let's look at an example with some negatives alongside the subtraction this time. Let's say we have 2 minus 3i, and from that we're subtracting, let's say negative 6 minus, let's say 4i. Then we'll rewrite this without parentheses. So we have 2 minus 3i, and now remember we've got to distribute the negative. So negative 1 times negative 6 is positive 6, and negative 1 times negative 4i is positive 4i. So we add 6 and we add 4i. And then we just add up the like terms, so we have 2 plus 6, which is 8, and negative 3i plus 4i, which is, again, just 1i. So the difference of these complex numbers is just 8 plus I, and again, it's just the difference of the real and the imaginary parts. So the difference between 2 and negative 6 is 8, and the difference between negative 3i and negative 4i is just 1i. So the difference of the two complex numbers is 8 plus I. And that's really all there is to adding and subtracting complex numbers. You just have to keep an eye on your signs, so if there are negatives involved, make sure you deal with those appropriately. You have to distribute a negative. If you're subtracting, distribute the negative through the complex number. Remember that a negative times a negative is a positive, and just add up your like terms, and then you should be golden. And here's a little set of 4 practice exercises you can try now that you've finished this lesson. Feel free to let me know what you get for them down in the comments, and we'll go over these examples in another lesson. But I think you'll find them pretty easy, and if you're struggling, just try writing them out very deliberately like we did in this lesson. It's nice to be able to zip through problems, but sometimes writing it out very carefully is all you need to get a better understanding and to stop making mistakes. But that's it for today, so I hope this video helped you understand how to add and subtract complex numbers. Let me know in the comments if you have any questions, need anything clarified, or have any other video requests. Thank you very much for watching. I'll see you next time, and be sure to subscribe for the swankiest math videos on the internet. And a big thanks to Valo, who, upon my request, kindly gave me permission to use his music in my math lessons. Link to his music in the description.